Hello, welcome to KHS Science. This is a required GCSE practical looking at specific heat capacity. Specific heat capacity is the amount of energy required to raise 1 kilogram of a material by 1 degree Celsius. The materials we're looking at here are aluminium, copper and brass. I'll start with the aluminium and I'll show you the equipment that we have. This is a power pack set at 12 volts. This is called an immersion heater, so called because you immerse it into something in order to heat it up. The power of the immersion heater can be read on the side as 50 watts. It's standing on a heat mat in case it gets hot, damages the worktop. Because it'll get hot, I'll obviously have to be very careful about moving the blocks after they've heated up, because some of them could get very hot. There is a timer. I switch on the power pack after reading the starting temperature of the metal block. The starting temperature of the aluminium was 23 degrees Celsius. As you guessed, I've already carried out the experiment over 10 minutes. I took the temperature every minute and I found the finishing temperature to be 42 degrees Celsius. So that means that the aluminium rose by 19 degrees Celsius over 10 minutes. I did the same thing for the brass and the copper. I'm just going to switch that off in case things get a bit hot. And I'll show you my comparative graphs. I have got the time plotted on the x-axis in seconds and the temperature on the y-axis in degrees Celsius. As you will see, both the brass and the copper showed a very similar pattern. The aluminium, however, took a lot longer to heat up. So when we actually plug numbers into a formula, the formula for specific heat capacity is power divided by mass times time divided by the increase in temperature. And using that formula, I found the specific heat capacity of the aluminium to be 1,578.9 joules per kilogram per degree Celsius. Now, the actual specific heat capacity of aluminium is 900 joules per kilogram per degree Celsius. That's a bit strange. The specific heat capacity of brass I found to be a beastly 666.67 joules per kilogram per degree Celsius, and it was exactly the same for copper. And in actual fact, the specific heat capacities for brass and copper, and I've just realised I've made a spelling mistake on that bottom line there. Of course, I've repeated brass instead of writing copper. I'm sure you'll forgive me for that. The specific heat capacities of brass and copper are very, very similar, being 380 for brass and 385 for copper. So aluminium has a larger specific heat capacity to brass or copper. That means it takes more energy to heat up 1 kilogram of aluminium 1 degree Celsius. But why was there such a difference in my findings to the actual findings? Have I done something dreadfully wrong? Is there something you could think of that would improve the accuracy of my results? Do you remember I said that I can feel it just from heating up a short time? These metal blocks, quite hot to the touch. There's maybe another clue here of something you could do to make the results more accurate. I'll leave that to you. Specific heat capacity.